Recording in progress.
So we're going to continue with section 3 today. I just wanted again to let everyone know that I'm still waiting for work from number of people. Like more than 10 people still owe me one or the other thing, so email it to me. Yes, I accept it. I'm waiting, so you can take advantage of it. Why not, right? So anyways, I go to section 6.3. That's what we started to work on. And we solved various equations, various trigonometric equations. It says load in this. I don't like that. Let me try to open this textbook again. Solvent pre-calculus. Sometimes it just gets corrupted. It's been opened. They opened it in the morning and it's just behaves kind of odd way. So anyways, never hurts to reload it. So it is still available. And my advice is again to download this free textbook to your device because they do disappear. I'm teaching online statistics class and that textbook disappeared. So it's inconvenience. I found another one, but it's like different sections, so it's a little different. And that's why download it. It's pretty straightforward. Just click that download key and everything be pretty straightforward. So anyways, let me go to the exercises story, refresh your memories on what we did in this section. There were exercises called equations. So that's different than, look at this again, download. So these are a little different because whenever you solve equations, you do same operations on both sides of equation. And then you find your unknown. And all of these equations, they have infinitely many solutions unless you start to restrict those on a unit circle, then they're finite solution. So there are various little exercises here that we solved as equations. I'm talking about problems that start at 35 and on. So those, I guess, key exercises here. And in some of these problems, you can find a nice answer. In some of them, you can't. Like, for example, in exercise 43, looks like we can't find nice answer, but that's okay. So we can use technology. So if they say that sine of theta is equal to 12 over 13, their equation is exact value of trig functions. I think I'm in the wrong section. Where am I? Oh, 7.3. Why did they go to 6.3? That's the stuff we already saw before. Just for fun, we can find a cosine because since I started, I think it never hurts to review a little bit, but in 7.3 went by accident to 6.3. So if I find cosine, remember it's a square root from 1 minus sine squared, right? Pythagorean theorem. But question is it positive or negative? So what's the sign? Positive or negative? And that's why they actually give us extra piece of information. And it says quadrant, no, here, quadrant number 2. So the quadrant number 2, which is here, has values for x coordinates that are negative because 0 is here. And we're talking about cosine, so that's on the x-axis, so that's negative. See, it could be positive, could be negative, so it is negative. Okay, so don't forget to keep the minus, and it's 1 minus sine squared, so that's 12/13 squared. So we got, what is that, 25/13 squared, something like that, which is 5/13. So one thing to realize that these values for sines, for cosines, they always less than 1 in absolute value. In other words, if it's a fraction, its numerator is smaller than denominator. It's never bigger than denominator. Because if you have it bigger, then there is no solution, because your functions, sine and cosine, they're both in between plus and minus. And then if you decide to continue with this exercise just to enjoy finding all of the 6, they say, remaining trig functions, so there are 6 of them, then you can find tangent, divide sine by cosine, etc. Don't take reciprocals. But that's not what we actually need here. So how can I quickly get where I need? I need to go back to the actual section and click on that 6.3, and that will bring me to the menu. Let me show you how you can quickly move instead of browsing through these pages, because it looks like it is annoying, right? They download a little bit on a slow side, and that's why. So 6.3, see, I highlight this with a cursor, and when I click on it, it should bring me back to the menu. And then I go to 7.3, see, it makes 6 and 7. We're already in 7. It's better, it's more fun to be in 7, I guess. We spend too much time with 6 anyways. So anyways, equations. I think it's good that I did this exercise because you can see the difference. Even though there is an equal sign in this exercise, it is not really equation because we're not looking for angle theta here. But now I will be looking for the angle theta. So they don't really tell me to solve equation in a problem number 43. They ask me to find other trig functions. So how would I solve that if I be in that 7.3? See, it depends what they asking you, because if you don't read what they ask, well, then you can do whatever, and it may be totally pointless. So let me do problem number 30. Looks like there is a bunch of cube roots of 3, so it doesn't look very nice. Let me do that. Number 30. So first of all, I'm gonna bring this to the kind of exercise that we saw in the previous little section. So it's 4 sine theta plus 3 radicals 3. And this is equal to square root of 3. Okay. So now I need to find the actual sign. So I'm gonna subtract this 3 roots of 3 on both sides. That's the first step. So I'm isolating function sine. That's my plan. So you get a 4 sine of theta, which is the same as a negative. So when I subtract from 1, 3 will be 2, right? So it'll be negative 2 square root 3. And then I'm gonna divide this by 4 on both sides. And I get something that is familiar. Something that is familiar, such as a sine of theta is equal to negative square root 3 over 2. So this enables me to look at my favorite unit circle. So you can look at it at the end of the textbook. I guess I'm not gonna browse every time there. I'll just locate function sine, which is square root 3 over 2. Since it's a function sine, it must be on y-axis. So minus radical 3 over 2 corresponds to 2 points on the unit circle. So these pictures are always symmetric. My unit circle is not ideal, that's why it doesn't look symmetric, but they are symmetric. Notice the other coordinate must be 1/2. Square root 3 over 2 nicely go with 1/2. So if it's 1/2, then the angle here should be like 60 degrees, but with a minus sign. But they want answers on the interval from 0 to 2 pi. So I'm gonna take, it's like pi over 3. 1, 2, 3, 4 pi over 3. And then 5 pi over 3. Or if you take negative pi over 3, that'd be going the opposite direction. So here the pair of solutions, so angle theta corresponds to 4 pi over 3, or to 5 pi over 3. So these two are the answers. And of course, plus period, as we saw already for function cosine is 2 pi, like that. Actually, analogously, you could have solved if they told you back there this equation. But what you needed to do is use arc cosine. So find the angle theta, you get a arc cosine because you don't know what angle corresponds to 12/13. So how would they solve that? I think that's an interesting question. In fact, we're gonna encounter something like that a little later. So sine is 12/13, that's here. So there will be an angle here, which is corresponding to arc cosine. Sorry, why did I put arc cosine? It's sine, so I should be careful. No, I looked here. Here is totally different. We don't need that. So it's arc sine. Sorry, arc sine, because there I wasn't solving the equation. I was doing something else. I was looking for cosine. So it's actually arc sine of that whatever fraction is, and that's one angle. Remember the power 13 range of that function. Arc sine is always here in between negative and positive pi over 2. But how do I describe the other one? That's the question. So how do I describe the other one? Well, the other one, I need to do something with this arc sine. So notice this arc sine is here as well. Let me get this again. I got carried away with this blue color. Okay. So notice if this is the angle here that we just found, right? Arc sine. Same exact, because picture is symmetric, will be here. So what I do, I take it off pi of 180. So this will be pi minus that arc sine. That's worth to think about. That's definitely worth to think about. So that way you will describe the second one. And of course, you also put 2 pi k. I guess it's already too much mess in here. And that's not what we're solving, but actually, that's what it is. And that's actually what these exercises say here. Use a calculator to calculate, to solve. So this section also has functions such as a tangent and secant. So I'd like to do a couple of problems of that type instead of being stuck with this calculator exercises, because I think that these exercises are more standard for tangent, for secant, and that stuff as well. So let me go there. So we use lots of these ideas in the calculus, such as the calculus 2 class, especially we work on these trig functions. We find so-called antiderivatives, derivatives of them. And that's why I spent time on it. Now, if you're not planning to take that class, I know for some majors, you don't need to take that. In Calc 1, I don't think we really get much into that. That's why I'm not pushing very hard on people to get very deeply into that, but you still want to be familiar with those functions, because people say you never know, you might eventually change your mind and decide to take one of these classes later. So 22 deals with a cotangent. So let me see how we work that out. Cotangent. And the angle here is not just theta, but 2 theta over 3. How about that? 2 thetas over 3, and this is a negative square root 3. Well, it turns out that cotangent is 1 over tangent, so the quick way, and there are actually 3 values that we care about for tangents that I didn't talk about, and that's why I selected this exercise. I want to tell you something new, the quick way to determine. So if you have a 45 degrees angle, then there'll be 1 on that line, because the unit circles the same exact height, 1. And that's going to be value of tangent of pi over 4. And if you have a root of 3, that's another popular angle that will correspond to 60 degrees. Or we like in trigonometry to say it's pi over 3, right? We just saw it. This pi over 3 friends in the previous exercise. So it's a tangent of square root of 3. Actually, tangent of 60 or pi over 3. And one more important value is 1 over. So it's someplace here, like a reciprocal of that. 1 over square root 3. And that one corresponds to tangent of pi over 6. Please notice that in that unit circle thing, they have those standard values like root of 3 over 2, 1/2, square root 4, square root 2 over 2. Basically just 3 of them. And the same with tangents. Square root 3, 1, and 1 over square root of 3. Where does it come from? It comes from similar triangles. I can show you, of course, this ideas, but I need a bigger picture so we can see it better. So you can, I think, convenient to realize that you can also quickly locate the angle, or you could always use a calculator and turn it in degrees mode, and it'll give you whatever you want. So anyways, let me take a look at one of those. Let's say the first one. So if I get a big circle, big circle, and the angle is pi over 3. So that's 60 degrees angle. So we already know that its values, it's like this one looks like a half, right? And that's cosine, and the sine is y coordinates, so that'd be radical 3 over 3, right? So I hope eventually you will believe me and find this faster than I, because we're talking only about pi over 3, pi over 6, and pi over 4 angles. So now we're trying to find tangent. Alex, this exercise is about cotangent. Well, cotangent is 1 over tangent, so we know tangent, then we get a cotangent. So this is a sine over cosine. And when you divide these, you will get that half that will disappear. So I divide what? I divide that first one, root of 3 over 2 by 1/2. So this is just a square root 3, right? Just do a little bit of arithmetic. I guess fast way is just to multiply the top and the bottom by 2. Doesn't change the fraction, but cancel these 2's and you get radical 3. So this point is it is more than 1. So 1 is someplace on the level of the top of a circle, but root of 3 is like 1.7. So we have square root 3. By the way, function tangent has period of pi. So for the angle period pi, you can also get the same value, root of 3. In other words, if you have angle, if you add pi or 3 pi over 3 with 1 pi over 3, so that's 4 pi over 3, which is the same as tangent of pi over 3. Because again, period of function tangent is pi. We say, well, the point is here, it's different. Yes, it is different, but tangent of both of those is the same because pi is a period. That's words to realize. So that picture actually goes like that. That point you also connect with the center and still hit that line of tangents. That's how you find it. So whether it's an angle bigger than pi, you still use the same thing. And of course, for the negative values, it's like a negative square root -1 here. Then you get tangent of whatever. Negative pi over 4. Right? Since function tangent is odd, you get minus in front of this tangent of pi over 4, which is -1. So this is something that I think is very helpful in order to solve these exercises, but one can say, so what about that one? Well, cotangent is 1 over tangent. So I'm going to use tangent to solve this, as well as for all the others that we have without sine and cosine, such as secant and cosecant. What I'm going to do is get their reciprocals. So it turns out knowing sine, cosine, and tangent is good enough. So what I just did, I reciprocated both sides of my little equation. So I bring myself to like 1 over square root 3 thing, right? Sorry, square root, I forgot square root. Should not forget square root because it's not going to be very happy. So square root is here. So I guess I'm going to continue on the left side of this. So it looks like we're to solve a little equation. And again, since it's cotangent, friend of tangent, they both have period of pi, not 2 pi. So my angle 2 thetas divided by 3 will deal with a negative point, right? So I can put negative pi over 6. Because it doesn't matter, we can always add period pi times k. Again, it's negative pi over 6 because if you have positive, it's up here, the mirror image down is negative. You don't want to start messing this up even more. But now I need to pull out my theta, so I have to do a little bit of arithmetic. I need to take a reciprocal of 2/3, which is 3 over 2, and times by 3 over 2 each of these pieces. every single piece in my little equation. So theta is pulled out. It looks like we can cancel this a little bit. So you get a negative pi over 4. So this is like definitely wouldn't be hard, wouldn't be that easy to guess, right? And that's 2 pi, actually 3 pi over 2 times k. So it could be all kinds of periods. Point of story is how to visualize it. And once again, put them on a circle. So I put point pi over 4 with a negative sign. I know I need to make it be positive to be from 0 to 2 pi, somewhere here. We'll do that. I can actually do it right away. I can see that we have 7/4 of pi, right? 7 of these pi's over 4. And now I need to get 3 pi over 2 as a period. So in order to be able to nicely put it together, I'm going to think of it as a 6 pi's over 4. So I have same denominator, right? I can cancel all this. So let me start adding and see what other points we get. So I need to add 6/4 of pi. So I add 1, 2, 3, 4, 5, 6, and I got that. And that's not it, because the period is times k, so it could keep going and going. So I add another 6/4 of pi. So let me get another color so we better see this. So it'll be 1, 2, 3, 4, 5, 6. I get that one. So I got a feeling there'll be one more here, but let's add it for just in case. 1, 2, 3, 4. Again, 1, 2, 3, 4, 5, 6. Yes, indeed. And now if you keep doing this again and again, you will keep getting more and more of these points. So my solutions are actually pi over 4. Actually, I'll put them here in the picture so you better see them. So it'll be 1 pi over 4, 3 pi's over 4, 5 pi's over 4, and 7 pi's over 4. But in order to put them with a single equation, I can see that from one to another, I can get by adding pi over 2 or 90 degrees. So what I can do is say pi over 4 plus pi over 2 times k. I think that'd be a pretty neat way to describe this solution, which is actually the same exact way as that one. But I think this one is not really giving you a very clear idea of what the actual solutions are, right? So I think it's nicer to write it like that. Like, Alex, do I have to do that? No, you don't. I think it's just giving you intuition what's actually going on in terms of solutions. But other than that, not really. And our goal is to practice again. So I will do another problem here. I just see one secant, number 27. We can do one more, 27. These problems are not very short, I know, and I still don't think that I will give you a quiz on this. I'll just do this exercise and let you relax a little bit, because I think you already saw quite a few things today. So I'm going to clean this tangent definition, because I think that's a pretty neat one. So, see, we used to have bigger textbook, and there were more information in it, such as for the calculus, we used to have calculus 1, 2, 3, and calculus 4, but then they started to cut it. So they threw away lots of nice and intuitive things, and that's why now the textbooks are being smaller, less units, but they expect you to get lots of material. And that's why may not be that fair, but anyways, let us just practice. So secant plus 6 is equal to -2. So we're going to subtract 6 on both sides. By the way, the spring schedule of classes is out, and I think the registration will start pretty soon. Just check the dates. My advice is register as soon as you can, because in the spring, historically, we have less classes. It's not just for math, for any major, we have less classes. And if you really want to try to register for spring as soon as you can, because those classes, the most popular, get filled up and closed pretty quickly. And that's the reason why sometimes you may want to take a class at some particular time or from some particular instructor, and you can't because the class is already full. So that's why advice is always try to do as soon as you possibly can the registration. So 1/cosine of theta is here. So it means that cosine of theta will be a reciprocal, -1/2. So I always boil it down to either sine and cosine. So if secant, it's 1/cosine. So I isolated the secant standard and then wrote it with 1/cosine. So I flipped this and I've got my favorite 1/2 or -1/2, doesn't matter. So we know that we're dealing now with 30 or 60 degrees angle. So let us see on our favorite unit circle what this is. So 1/2 is somewhere right here in the middle, cosine. So it'd be right there. So what points, it's not one, there are 2 of them, on a unit circle correspond to this cosine or to this x coordinate? What are the angles? And looks like the angles are dealing with pi/3. So this is going to be 2 pi/3. And the other will be, let's see, -2 pi/3. Yeah, you could technically say that, but they want you to put 4 pi/3. And we already saw that there are various ways to produce your solutions. Like here I had it this way, and there was another way. So there are actually infinitely many ways to produce the answers if you have general solution, right? Depends on your period. But if you look at the solution, which is on the interval from 0 to 2 pi, then of course there'll be only one that I already have here for you. It's 2 pi/3 and 4 pi/3, just those 2 points. So you see that if you have a cosine function with only angle theta, then all you do is just add period of 2 pi, and to write this angles, I can say it could be put together with one equation, but plus minus 2 pi/3 with a period 2 pi k. See, we have that description. So again, it's pretty neat, and I hope you start to like this. So I would say the next group that was using a calculator, I just tried to show you one of those problems, and you need to be dealing with arc functions. So it's really something to watch out. There are more equations here. So I'm showing you all that to say that I'm not really trying to solve every single little exercise here. When we have a trigonometry class, main idea is to introduce you with all of those, but then we don't have to bother with so many of them. So I can maybe do one more here, because some of them sometimes get a little bit tricky. But I don't see many tricky ones here. They're pretty much similar, but anyways, some of them expect you to do something like solving the factoring type of exercise. Like, for example, problem number 73. So that says 2 sine squared. Oh, I said that was the last exercise. Maybe I'll just factor it for you and then you can try to finish it on your own. I'm not going to give a quiz, I promise. I just want to show you that there is a standard way to solve these exercises using factoring methods. Analogous to if you had 2x squared minus 5x plus 3, since it's equal to 0, then you get a 2 factors, and 2x squared factors only one way, 2x times x, and the 3 factors also only one way, and this will be 3 times 1, right? So if I put 3 like that and 1 like that, looks like that's gonna work, right? Because inside product is 3x and the outside product will be 2x. 3 and 2 is exactly 5. And this way I can actually put this 2 parentheses. So it'll be 2x, but now instead of x, we have sine. So it'll be 2 sine minus 3. And the other factor will be a sine theta minus 1. So you have product of 2 factors equal to 0, which is possible only when each of those factors is 0, not either one or the other. Because if they both are not equal to 0, well, then you never get 0 when you have product. And then you solve this equation, such as first will be sine theta is 1, second will be sine theta is equal to 3 over 2. That's not possible. That was exercise similar to the midterm second part. I gave you exercise that was not possible, so it's much easier to just say no solution. And for the first one, sine is equal to 1 only up here. You see that point? You say yes, yes, Alex, we see it enough. So, okay, so theta will be pi over 2. And of course, plus period 2 pi k. So the exercise turned out to be nice because one of the answers was not possible because sine is never 3 over 2, because sine can only be in between of -1 and +1. If somebody says 3 over 2, it's out of the range of the function sine. So number 73 happened to be a pretty short exercise, right? So some other problems here involved a little bit of trig identities. If you will be actually working on those in the next sections. So I think that this set of exercises needs a bit of preparation to do problems like, say, this one. What does preparation mean? Well, write this as sine over cosine, that's cosine over sine, the clear denominator. So you do some algebra basically, and same with exercises like cosecant squared and cotangent. So you really want to either recall the relationship between of those or write everything with sines and cosines. So usually the way to do problems is just to get rid of all of those functions, but keep sine and cosine, and that way you will end up with something neat. But again, I don't think it's a topic for this section, so I'm gonna end with 7.3 because that'd be 7.4, 7.5 when we do all this use of various trig identities. That's what we're gonna do next time. And now, before to end, I don't give you a quiz, but I want to reiterate, I'm still waiting for lots of people can improve their grade that I put on Canvas. It's like preliminary grade, but you should do this because time passes, about a week passed by, right, since the exam, and I didn't get any, well, some people did, but not too many. So if you gonna be taking the final exam, which is gonna be the same format, like a midterm, those people that turn it in, seems that it worked for them pretty well. But after the midterm, after the final, I'm not gonna have so much time just to wait, because I will have to submit your grades. So I will be able to wait like for a week, even less than that, because usually the following Monday after the semester is over, I must input grades in the system. That's why, first of all, you should not worry what's on Canvas, because Canvas absolutely has nothing to do with what the college is going to get. Of course, it has something to do. You see your grade on Canvas, but if somebody wonders, there's some points on it, some other things. It's Canvas. It just tries to help, but it shouldn't. So no worries about that. Just look at your grade, and that's what you're getting on this class. And again, if you want to get it better, I already told you what to do. So usually, if someone missed something like homework or even midterm, some people still did not send me their midterm. I'm just wondering if they want to continue in this class, because if not, I will be emailing, of course, next week again to refresh memories. If not, I'll have to drop some people, because I don't want to fail anyone just because they decided not to continue with this. So anyways, I guess I'm gonna end it for today, and we're gonna continue on Thursday. So thank you for being here, and if you have any questions, then please let me know what's on your mind. If not, you can just enjoy